Hello, this is Modumath Tape 2.5. The subject is subtracting fractions. Modumath Text 2.5 goes with the tape. Open to this text now. Keep pencil and paper handy to solve problems and take notes. If you have any difficulties, either with the material or the machine, ask someone to help you. Subtracting fractions is easy enough once you get past one little trouble spot. When we studied subtraction before, we saw that as long as we were working with whole numbers, it's possible only to subtract a smaller number from a larger number, unless the two are equal. You can't do it the other way around. The same is true of subtracting fractions, at least the part we'll learn today. But so far, we have no way of knowing which of two fractions is smaller and which is larger. That's what we'll consider now. The basic idea is familiar. We used it with the whole numbers. Given any two fractions, the one that's further to the right on the number line is larger. This gives us a start, because it's easy to see that if two fractions have the same denominator, for example, 3/8 and 5/8, the one with the bigger numerator will be to the right of the other, and therefore it will be larger. We write this with a sideways V as shown. The open end of the V is next to the larger number. Here we've plotted two fractions, 4/5 and 7/5. The denominators are the same. And of the numerators, 7 is larger than 4. And sure enough, you can see for yourself that 7/5 is to the right of 4/5 on the number line. Conclusion, 7/5 is the larger number. Here are some to try yourself. For each pair of fractions, check the larger of the two. Work by comparing numerators. Let's look at the answers. In the first problem, 3 is less than 6. So 6/8 is greater than 3/8. In the next, 9 is greater than 7. So 9/10 is greater than 7/10. Go over the rest yourself. If you had any difficulty, play back the tape from the beginning. Otherwise, you're ready to go ahead. What happens if the two fractions don't have the same denominator? How can you compare them in that case? You may have guessed the answer. Just write them with a common denominator and then apply the rule. Suppose, for example, that we're asked to compare 2/7 and 1/3. We use the common denominator 21, which is 7 times 3. And we note 2/7 equals 2 times 3 over 7 times 3, or 6 over 21. 1/3 equals 1 times 7 over 3 times 7. Or 7 over 21. 6 is less than 7, so 6 over 21 is less than 7 over 21. Or, returning to our original problem, 2/7 is less than 1/3. Let's look at another example. The two fractions we're comparing are 5/6 and 7/10. We'll use the common denominator 60. We get it by multiplying 6 and 10. 5/6 equals 5 times 10 over 6 times 10, or 50 over 60. 7/10 equals 7 times 6 over 10 times 6, or 42 over 60. 50 is greater than 42, so 50 over 60 is greater than 42 over 60. Or, returning to our original problem, 5/6 is greater than 7/10. Notice we didn't bother to find the least common denominator. In comparing two fractions, or for that matter in actually subtracting two fractions, it's not always worth the trouble to find the least common denominator. The denominator we get by multiplying the two given denominators does the job as well, and may be less work in the long run. Compare these two fractions yourself, 5/8 and 4/7. To start, write both fractions with a common denominator, and then tell which is larger. How does your work compare with this? If you had any trouble, it might be because you forgot how to find common denominators. If so, review this topic in Modumath 2.4. Or perhaps you did all right with the common denominators, but just didn't remember how to compare. In that case, go back to the earlier ideas of this tape. Of course, if you got the problem right, you're ready to go ahead. At this point, let's remind ourselves of why we're doing all this. The reason for comparing fractions is that when we subtract, we want to be sure we're really subtracting a smaller number from a larger. Once we're satisfied about this, the rest is easy. Here's the problem 5/15 minus 3/15. Since the denominators are the same, all the action takes place in the numerators. We need merely compute 5 minus 3 all over 15, which of course equals 2/15. We can check this just as we did in subtracting whole numbers. We add 2/15 and 3/15. The sum should be 5/15, and in fact it is. By the way, you can see all of this on the number line. Here's 5/15. Here's 3/15. And you can see that the length of the last arrow must be 2/15. But you know something about subtraction by now, so the number line may not be necessary. Let's try another example. 9/10 minus 1/7. Here there isn't much question about larger and smaller numbers. Just looking at the two numbers, we'd all agree that 9/10 is greater than 1/7. All the same, Before we can do the subtraction, we have to write the two fractions with a common denominator. The denominator we'll choose is 10 times 7, or 70. 9/10 equals 9 times 7 over 10 times 7, which equals 63 over 70. 1/7 equals 1 times 10 over 7 times 10, or 10 over 70. So, 9/10 minus 1/7 equals 63 over 70 minus 10 over 70. Since 63 minus 10 is 53, the answer is 53 over 70. Check your answer later if you want to. What happens if we're subtracting mixed numbers? For example, 2 1/4 minus 1 1/2. The safest thing is to change them both to improper fractions and use the rules for fractions. 2 1/4 equals 9/4. 1 1/2 equals 3/2. Or, multiplying through by 2, 6/4. So 2 1/4 minus 1 1/2 equals 9/4 minus 6/4, which is 9 minus 6 over 4, or 3/4. Now that you know how to subtract fractions, you may be wondering when we have to do it. Well, just as with whole numbers, we subtract fractions in at least two kinds of problems: take away and missing addend. Here is a straightforward take-away problem. Mr. Jones has 4 1/2 oranges. He uses 1 3/4 oranges. How many oranges are left? To get the answer, we compute 4 1/2 minus 1 3/4. Changing each mixed number to an improper fraction, the problem becomes 9/2 minus 7/4. Multiplying 9/2 through by 2, that's equal to 18/4 minus 7/4. The answer is 11/4, or 2 3/4 oranges. Now try this one. Mr. Smith figures he'll need 3/4 of a gallon of paint for a job he's doing. He has 1/3 of a gallon. How much paint does he need? This time we're looking for a missing addend. We're asking 1/3 plus what equals 3/4. Let's give the missing addend a name. Call it n. Then n equals 3/4 minus 1/3, Or using a common denominator of 12, n equals 9/12 minus 4/12. So n equals 5/12 of a gallon. Let's review the important ideas of this tape. We saw that the first step in subtracting fractions is to express them with a common denominator. This serves two purposes. It allows us to make sure that the second fraction is really smaller than or equal to the first. And this being settled, it allows us to go on with the actual subtraction. Once we've expressed the two fractions with a common denominator, the answer is a fraction with that same denominator and a numerator equal to the difference of the two given numerators. That's the most important part of subtracting fractions, but we looked at a few more things. We saw that we can easily subtract mixed numbers by changing them to improper fractions. And finally, we tried a couple of word problems. If you're having any difficulty with the ideas of this tape, play it again or ask someone to help you. Otherwise, you're ready to try the problems in your Modumath text.